Hello, class. Welcome to Preliminary Notes to Case Study 2, Part 2. The idea I kind of have for class is breaking it up into smaller, maybe 10 to 20-minute sections of notes. Now, this entire note set is what we would have covered in 1 hour and 15-minute class, so about half a week of lecture. Last time we were talking about type 1 and type 2 errors. Just a reminder, a type 1 error is rejecting a true null hypothesis, and a type 2 error is failing to reject a false null hypothesis. We'll never know when we made one of these errors. We went through a couple examples and talked about how we can pick our significance level based off of what error you feel is worse. Today, we are going to move on to descriptive statistics. We have two types of descriptive statistics: numerical measures. This includes measures of center, measures of spread. We also have graphical descriptive statistics. Root word there, think graphs, histograms, box plot, also commonly called box and whisker plots. First, I would like to talk about the two types of measures of center. Okay, we have sample average or sample mean and sample median. Sample average, that's the way you calculate any average. So if you're wanting to calculate an average, your quiz average for my class, what are you going to do? You're going to add up all your quizzes, divide by the number of quizzes we took. This capital sigma here is telling us let's sum all of our x values starting at x1 for I up until our sample size. Also, let's note up here before we started this chart, let x1, x2, x3, all the way to xn denote the sample of measurements that were collected. First measure of center, that's our sample mean, sample average. Then we have sample median. This is the value that's in the middle of an ordered list of data. Okay. Note that you can average the two middle values when n is even. So to just do a short example off to the side here, if I had the numbers 1, 2, 3 in my data set, the median would be 2. If I had the numbers 1, 2, 3, 4, I would take the average of these two middle ones, giving me a median of 2.5. That's our two measures of center, sample average, sample median. Our two measures of spread, we have sample standard deviation and the range. So again, looking at this formula for sample standard deviation, that capital sigma is just telling us to sum. On the next page, we're going to get into how we do this calculation a little bit more. Also, just a note, you do not have to memorize this formula. I will post a separate video showing you how to do this calculation in your calculator. Another measure of spread is going to be your range. That's when you take the largest value in your data set and you subtract the smallest value from it. That gives you the range of how far your data stretches. We will use X bar as our main measure of center and S as our main measure of spread. So X bar. So X bar, that's up here. Okay, there's a calculation on how to calculate it. So X bar is our main measure of center, and S, again, we'll have a calculation on how to calculate it. That's going to be our main measure of spread. Something to note before we go on to the next page here is that S is our sample standard deviation. S squared is our sample variance. So that means if we take our sample standard deviation and square it, that gives us the sample variance. So just to make sure I go over some of these things, I have abbreviated sample standard deviation. That's just S. So if I take S and I square it, I get my sample variance. So now what I want to do on the next page is I have a small data set and I want to work on finding the sample average, sample median, sample standard deviation, and and the sample range for this data set. Okay, so first we want to start with calculating the average. So in order to calculate the average, what we're going to do is we are going to sum up that data set and divide by the number of samples in our data set. What is our sample size for this data set? Yes, it is 5 because we have 1, 2, 3, 4, 5 data points. So then here you see I have set up X bar, sum them all up, divide by 5. When you type that in your calculator, you should get 3.4. Okay, we had to calculate sample average first because we need that in order to calculate the sample standard deviation, which is the next calculation I'm gonna wanna show you here on this chart, okay? So if you could just ignore the part that says type equation here, that shouldn't be there, okay? We have this chart that we're gonna fill out. And what we wanna start with is we wanna start with, well, what's the formula for our sample standard deviation? We take the sum starting from 1 all the way to n of all of our x values. So we take our first x point, our data point, subtract the mean, square it. And then we do that for all our other data points. Once we get that, we divide it by n minus 1, and we take the square root. Now the thing is, solving this numerator is what we're going to do in this chart. So I'm building this chart so that we can calculate this summation, okay? So first I take each data point. Notice I have them listed down my chart. Take my data point 1.5, subtract the mean of 3.4. What do I get? Negative 1.9. Then in my next column, I want to square negative 1.9. And doing that in my calculator, I get 3.61. Notice everything in this last column should be positive because if it's a negative number and you square it, you should get a positive number. If it's a positive number and you square it, you should still get a positive number. So what we're going to do is we're going to complete this chart. So 2.6 minus 3.4. Okay. If you want to try to fill this chart out on your own, now might be a good time to kind of just pause and fill it out on your paper and then just make sure you're getting what I get. So when you do that, you should get negative 0.8, okay? And then in this next box, what we're gonna do is we're gonna take negative 0.8, square it, and we get 0.64, okay? I kind of went out of the boxes a little bit, so I'm gonna zoom in a little more for this next one. Okay, so first I'm gonna take 3.5 and subtract 3.4, and that's gonna give me 0.1. Then in this box, I'm gonna take 0.1, I'm gonna square it, type in my calculator, gives me 0.01. All right, you're gonna do that for 4.2 and 5.2, and you should get 0.8 here. When you square 0.8, you get 0.64, and you should get 0.18 here. Square it, get 3.24. So now we almost have our chart all the way filled in. Now notice I put a bar right here. We're not concerned with the sum of that column. We're concerned with the sum of the last column because notice at the top it says x minus x bar squared. And that is what is here inside the top of our numerator underneath the square root. Each x value minus x bar squared. And then we sum them all up. So that's the last thing we do. In this very last box here, we take each of these values we calculated, we add them up. And when you add them up, you should get 8.14. All right, so now we have the numerator of this S calculation. So now I'm going to come over here back to S, okay, and 8.14, that's what we saw for in the numerator. Okay, n minus 1, well, we know that our n is 5, so n minus 1 is going to be 4. So S is equal to the square root of 8.1 divided by 4. We do that in our calculator. And with these calculations for S, anytime you have a square root, I'm going to say it go to at least 4 or more decimal points, you get 1.426.5. So that's S. So we have X bar, we have S. Now, what else do we need? We needed the sample median. So the sample median is the middlemost data point in an ordered list. So if you notice the way the data set is up here, it is in order from smallest to biggest. So the sample median, when you have a bigger data set, the way I would solve it is start at each end, cross out one, then go into the next one, and keep doing that until you arrive at the middlemost point. This is your sample median. 3.5. Sample range, that's the last one. You take, I'm going to do this calculation up here. You take the largest number minus the smallest number, and that's going to give you your range each time. So you take 5.2, you subtract 1.5, and you should get the number 3.7. Okay, so if I scroll down, then you can see that I plugged all of those values into this chart down here. My sample average was 3.4, the median was 3.5, my sample standard deviation was 1.4265, while my sample range was 3.7. Okay, so now what I have over here on the left side of our screen is that from here on out, we're going to use technology to calculate X bar and S, okay? This chart that I have is the easiest way, I think, to calculate S by hand, but computers, any of your calculators that you have will calculate this for you. And again, I will work on posting a video for this later in the week so that you know how to do this in your calculator. If you would like, you could look at how to do it on Excel and page 34 of your case study manual. I will talk about Stat Crunch. That is something that my Stat Lab, your homework website, has to offer. And I'll post a video about the calculator. Now I want you to take a moment and calculate those 4 numerical methods or descriptive statistics for this following data set. And make a note that now instead of having 5.2, we have the number 52. So if you'd like, take a moment, pause right here, and work on calculating, the sample average, sample median, standard deviation, and the range for this data set. Okay, now that you've calculated that, you should have gotten, for this data set, those answers: 12.76, 3.5, 21.96, and 50.5. Something to note, the reason I wanted to do this example is that 52 is what we would call an outlier. And an outlier is going to be any number that is much bigger or much smaller than the rest of the numbers in the data set. So if you look at the previous numbers, 1.5, 2.6, 3.5, 4.2, those are all low numbers, lower than 10. And then you have 52, much bigger. So 52 would be considered an outlier here. And if you notice, if you compare, this box here to this box here, the median is not affected at all by outliers. The median remains exactly the same, but what the other values are all affected by outliers. The range being very, very highly affected. The sample average also being highly affected. 12.76 is much different than our 3.4. Also, our sample standard deviation is now inflated as well. Sample standard deviation, if we go back to the previous page, this is talking about a measure of spread. It's telling us how far our data is spread from left to right on the number line. So since now, looking at this data set again, we've got a larger spread. We go from 1.5 to 52, which does make our spread on the number line bigger. That inflates our sample standard deviation and our sample range. So again, an outlier is just any number that's much bigger or much smaller than all the other numbers in the list. All right, now I would like to look at histograms. So histograms are similar to bar graphs, but all the bar graphs are touching each other. So here we have, I'll go through them one by one. And please take note of the names. You are going to want to be able to know the names and recognize the shape. So here we have our bars and they're all touching each other. Skewed right means that there's a tail off to the right. Skewed left means that we have a tail off to the left. Now, anytime you see a histogram, I am going to encourage you to take your pen like I'm doing and draw a line over it just to kind of get a good idea of what that shape is that we're looking at, okay? And then I want you to use the words that I'm circling on this page to help describe the shape that you see. So approximately uniform, this is going to be one that has like a kind of boxy shape. You see uniform, meaning almost all of the bars are close to the same height. Now, if it was a perfect uniform, it would look straight across like that. This is approximately uniform because it's not exactly uniform, but it's pretty close to being all the same. The next one we have is approximately normal. Approximately normal is going to be a big one. You want to make sure you can recognize this. Based on talking about the normal distribution before spring break, the words that we use to describe this is a symmetric bell-shaped curve. So we've been drawing and shading normal distributions that look something like this. Okay, and I'm going to do the same thing with this. I'm just going to draw my bell-shaped curve over it. That's going to be approximately normal. Then we have symmetric and bimodal. So it's got bimodal, means it's got two modes. There's two places where we have the most data. Here is where we have the most data, and here. So if I draw my pen over it, it's going to look something like that-ish, okay? It's symmetric because if I fold it in half, it's almost exactly the same on both sides, and it's bimodal because there's two peaks going on, two places where we have the most data. All right, so what I have for these next couple pages is just looking at histograms, kind of talking about them some. So example 1, 2008 home run derby, estimated distances of Josh Hamilton's home runs in round 1, ordered from smallest to largest. So if we were to collect the median, it's already ordered from smallest to largest for us. That's nice. All right. So a couple things I would like to point out here is how we build this histogram. So this histogram is based off of this data set that you have listed above. So right here, looking at the bottom from 360 to 380, that bar is telling us how much data is between 360 and 380. And if we look up at the top, yeah, we only have one data point that falls between the numbers 360 and 380. It's 361, okay? Let's go to the next bar, 380 to 400. And put a little star here. So according to this histogram, it's telling me that I have 5 data points between 380 and 400. Notice that that y-axis is called the frequency. So it's saying, well, how frequent of data, like how many data points do I have between 380 and 400? So if we go to the top, we have 1, 2, 3, 4, 5. So 381, 381, 382, 389, 393. Those are the 5 data points we have that fall between 380 and 400. Okay. So just an idea of how to build a histogram and just being able to look at it and tell me the frequency. So like how many data points fall between the numbers 440 and 480. So 440 and 480 is here, and here we have a frequency of 7, and here we have a frequency of 3. So if we add those together, we have 10 data points that fall between 440 and 480, which you can then confirm by physically counting the number of data points in our data set up above. Now, the next thing I want to kind of talk about is the shape of this histogram. So this histogram, it doesn't like really super scream out any one of these, but something that we're gonna really try to look for when we can is this approximately normal. It's going to be really helpful for us moving forward if when we collect data, we can see something that's kind of approximately normal. So this isn't perfect, but if you watch, I can kind of draw a slightly, not perfectly symmetrical, but this would be a very, very rough approximately normal. Now, on the other hand, I would also agree that it is maybe very, very slightly skewed to the left. Okay, so this bar right here kind of sticks out a little high to be really approximately skewed left. But if I were to ever ask you, to describe a shape for me, all you have to do is just kind of defend it in your own way. If you think this looks approximately skewed left, or if you think this is approximately normal, that's good. Either one of those shapes is going to be helpful for us to make sure we know and we can recognize. All right, let's look at this next one. 20 random people reported the amount of time in hours of television that they typically watch per day. So again, you can look at these groupings 0 through 2. We have 3 data values. 2 to 4, we have 5 data values. Take a moment right now, pause the screen, and think about what shape you would describe this as. So this is something that I would definitely call approximately normal. It's almost perfectly symmetrical. Okay, you see that this bar is a little bit higher than this bar, so not perfectly symmetrical, but we definitely got this bell-shaped curve going on. I would call this histogram approximately normal. Example 3, histogram of 90 GPAs in instructor's class. Okay, again, take a moment, pause the screen, think about what you would call this distribution. So when I draw my curve over the top of it, I notice that I have this pretty distinct tail that's coming off and to the left. So we're going to call this left skewed or skewed left. And then this next page here are some StatCrunch directions, okay? I definitely encourage you whenever you're working on your descriptive statistics homework to play around with StatCrunch a little bit. StatCrunch is how I will give you data and histograms in the future on quizzes and exams. And these instructions go through, so these instructions are embedded into your notes, and they go through, well, how do I get StatCrunch to list any of these things or make any of these graphs for me? So if you have a problem that gives you data, it's also going to give you this little rectangle icon, okay? And that's what you will always click on, and it will open your data into StatCrunch. And then that's when you can follow these instructions on either histogram practice or summary statistics in histogram on StatCrunch, or summary statistics and histogram practice with your own data. Okay, and that is where I'm going to go ahead and end preliminary notes to case study 2, part 2.